I decided to put section 4, comparing characteristics of functions, on its own separate video because I'm going to take a little bit of time to go back and review some content with you guys. Because I noticed in class that this is the one that consistently we're having the hardest time with. I think it's because there's a lot of vocabulary on top of math that you've got to remember. So I'm going to do a really quick little review before we get to section 4. That's numbers 13, 14, 15, and 16. I'm going to go over a little bit of review before we get started. So there are several words that they ask you about in the questions that are about to follow. One of those words is slope. Now, we've talked about it, and I want to make sure that you remember, slope is just another word for rate of change. And we have talked a ton about a rate of change. So if I were going to find the rate of change for this particular function here that I'm going to graph, remember that your rate of change, and it's really darn confusing. Okay, to find your rate of change, you just pick a couple of points that hit in corners. They're not necessarily going to be given to you like the ones that I just found, that I just placed for you. You just find two points where it hits in the corner so it's easier to count. Then I like to draw a little imaginary triangle right there, and then I count. If I had to travel from this point to this point, how much should I have to go up? In this case, I had to go from a 2 up to a 4, so that means I went up by 2. I had to go over from 1 to 2, so that's a 1. My rate of change, remember, is your change in your y over the top of your change in x. One way to remember that is rise over run. Your up and down change comes first. Your left to right change goes second. That is really confusing because back when we taught you guys how to graph, last year, several years ago, you guys know that you always graph your x first and then your y second. That's what makes slope so confusing because you actually do your vertical change, that is whether you had to go up or down, whether you had to go left or right. Up or down goes on top, left to right goes on the bottom. So we had to go up 2, we had to go over to the right. So 2 over 1 simplifies to a 2. I know for sure it's a positive 2 because as I'm going from left to right across the graph, it's slanting upward. So my slope, also known as rate of change, remember guys, this means exactly the same thing. Slope and rate of change is the same thing. So in this case, our slope or our rate of change is a 2. Another part of the function that they're going to be asking you a lot of questions about very soon is, aside from the slope, they're also going to ask you for the Y-intercept. This is a term that is relatively new to us, but what it actually means is not new to us because we've actually worked with it before. Y-intercept. Let's talk about what the word intercept means. When you're playing football, if a team is trying to pass the football from one player to another, and if a member of the opposing team gets in the way of the ball, that means they've kind of gotten in the way of that pass, they've intercepted that pass. Well, a Y-intercept on a graph kind of means the same thing. Hopefully we know that this is our x-axis, this line right here. This line right here is our y-axis. The y-intercept is wherever the graph intercepts the y-axis. So on our graph that we have right here as an example, the y-intercept would be right here because this is where the graph intercepts with the y-axis. So the y-intercept for this graph would be a 0 because that's where it hits the y-axis. Let me do another example of a y-intercept. Get this one out of the way here. Cut. There we go. Okay, so I'm going to add a line here. So in this case, the place where our graph intercepts with the y-axis, that means where it hits it. In this case, now the y-intercept is a 2. The y-intercept is a 2. Now, in both cases, you'll notice that in order for a graph to actually hit the y-axis, the only way that the graph can hit the y-axis, which the y-axis is right here in the middle of the x-axis. So in order for a graph to hit the y-axis, your x value always has to be a 0, because in order for the graph to hit right here in the middle, or right here on the y-axis, it's right in the middle of the x-axis. So if I were to actually ask you to tell me what point this graph is right here. Now the y-intercept is a 2, but if I actually asked you what ordered pair it represents, it would be 0, 2, because you don't go left or right on the x-axis, you simply go up to the 2, so it would be a 0, 2. So in this case, the x is a 0, the y is a 2. It's actually that way for every single time you have a y-intercept. Let me show you one more, just so that you see. So let me graph another line here. So in this case, my y-intercept, that is where the graph hits the y-axis, is a 4, and it's still right here at the 0 on the x-axis. So the y-intercept, don't get y-intercept and ordered pair backwards, the y-intercept is a 4, because it hits that y-axis at a 4. The ordered pair is a 0, 4, because to graph it, you don't go left or right, you're just right there at 0 on the x-axis, you just go up 4. That's going to be really super important in a minute. So every single time that you have a y-intercept, the x value is always a 0. Has to be that way, because the only way that the graph can hit the y-axis is if it goes right here in the middle of the x-axis, where the x is equal to 0. Now the reason that I say, even though the term y-intercept is relatively new to us, you've actually had some experience with the idea of what the y-intercept does. Let's say that this graph represents a real-life situation where this is, I don't know, and this will probably be very unrealistic right now, but let's say the number of hours that you're in the car and the number of, well, no, that's a really ridiculous idea. Let's say this is the number of, well, let's just say it. Okay, this is the number of hours you're in the car, because I'm drawing a blank right now, and this represents the number of miles that you've gone. So, no, you know what? I really don't like that example at all. Sorry, guys. Okay, let's do a different one. Let's say that this is the number of months that you've deposited money into your checking account, and then this is the amount of money that you have in your account. So after 1 month, you have somewhere between $4 and $5 in your account. At 2 months, you have a little bit more than $3 in your account. At 3 months, you have $6 in your account, etc., etc. Well, at 0 months, you have what looks like, $4 in your account, because this point right here is at 0, 4. So that must mean that you started out with $4 in your account before you started putting more money in it. Now, obviously, we're not putting a lot of money in our account every single time, because we're not going up very quickly. But bottom line, if this x-axis represents the number of months that you deposited money, and this represents the amount of money you have in your account, at 0 months, right here, so you haven't actually started putting money into your account yet, you already had $1, $2, $3, $4. So that must mean that you started with $4 in your account. So before you even started putting money into your account, you started with 4. Those of you guys that have done your vocab projects hopefully will remember that the amount that you start with is called the initial amount. Just like the initial of your name is at the start or the beginning of your name, the amount of money that is in your account at the very beginning is $4, which is your initial amount. So take a look. Your initial amount is always going to be right here on your y-axis. So actually, what I've just shown you is that the y-intercept and the initial amount actually means the same thing. So your y-intercept, where it hits the y-axis, whenever x equals 0, is actually the same thing as your initial amount. And we're about to see. So just like slope and rate of change means the same thing, y-intercept and initial amount means the same thing, because both of them represent what you started with. That's going to be some very important reminders as we go through to our first questions. So number 13 says that function 1 is represented by the equation y equals negative 2x plus 1, and another linear function, function 2, is represented by the table below. So function 2 is the table, function 1 is the equation. Which statement is true? So it's asking us here about slopes and about y-intercepts of functions. So first of all, the slopes for the two functions are equal. The slope of function 2 is greater than the slope of function 1. Well, let's pick between those two first and see if either of those two is right. So the first thing we need to figure out, well, what the heck is the slope for both of them? I'm going to rewrite the equation over here and remind you about how to just look at an equation and to be able to tell what the slope is. Remember that slope also means rate of change. And your rate of change means your change in your y depending on your change in your x. So pretend for a second that x is 1. What would that make y? So negative 2, instead of negative 2 times x, do negative 2 times 1. That would be a negative 2. Negative 2 plus 1 means that y would be a negative 1. Let's say that x is a 2. Negative 2 times a positive 2 would be a negative 4. Negative 4 plus 1 would be a negative 3. Let's do one more. Let's assume that x is a 3. Negative 2 times 3 is a negative 6. Negative 6 plus 1 is a negative 5. So you'll notice that every time your x goes up by 1, what happens to your y? It goes down by 2. Remember how your rate of change is your change in y over your change in x? So a negative 2 over a 1. Negative 2 over 1 simplifies to a negative 2. Oh my goodness, look at this. The number in front of the x, we've talked about this before, actually, when it's in this format, always tells you your rate of change. So when it's in the form of an equation, that is the easiest rate of change to identify, because when it's in this format of y equals a number in front of the x and then plus or minus a number, that number in front of your x is always your rate of change. So that means, since rate of change and slope mean exactly the same thing, that means that if the rate of change for the equation is a negative 2, that means that the slope is also a negative 2. So the slope for the first function is a negative 2. Now we got to figure out the rate of change for the table. So I got to figure out my change in y. Remember, it's going to be my change in y over my change in x. So to go from a positive 5 down to a negative 7, this is not a difference of 2. So if I go down, so 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. So if I go all the way down from the positive 5 all the way down to a negative 7, I'm actually going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm actually going down 12 places. To go from a negative 1 up to a positive 2, I'm going to use my same little drawing over here. So from a negative 1 up to a positive 2, I go up 1, 2, and 3. So this is up a positive 3. So change in y is that negative 12 over my change in x, which is a positive 3. Negative 12 divided by a positive 3 is a negative 4. So my slope, or my rate of change for my first function, is a negative 2. For the table, it's a negative 4. So when it says the slopes for the two functions are equal, we know that's out. The slope of function 2 is greater than the slope of function 1. Well, no. Negative 4 is not bigger than negative 2. Negative 4 is actually smaller than negative 2. So that one can't be it either. So remember that the y-intercept, because now we got to narrow it down between these two. It says the y-intercept for the two functions are equal, or the y-intercept is greater for function 1 than it is for function 2. How do we figure out the y-intercept? Remember that your y-intercept is the same thing as your initial amount, and your initial amount is whatever your y value is if your x value is 0. So let's figure out what our y value would be. So we know I can erase all this work right here because I know I just did all that work to get the slopes. So let's get rid of all this for a second because now we got to do some work to do the y-intercept. So again, your y-intercept is whatever your y value equals. Remember, for it to hit the y-axis, your x has to be a 0. So I'm going to take my equation here. So it's negative 2x plus 1. So negative 2 times 0, negative 2 times 0 would be 0. 0 plus 1 would be a 1. So that means that if x is 0, y is a 1. That also helps me to prove, remember that when this equation is in this format, we're going to talk about this a lot more when we get to slope-intercept form in a little bit. This number here is always your y-intercept. As long as it's in the format, y equals something x plus a number. This is always your y-intercept. So my y-intercept for function 1 is a 1. So that's my y-intercept for function 1. So y-intercept for function 1 equals a 1. Now we got to figure out the y-intercept for this one. Again, remember, your y-intercept is whatever your y value is if your x is 0. So let's figure out if this x were a 0, what would my y be? So that means that to go from a negative 1 to a 0, it would have to go up 1. Hopefully we remember from when we found the rate of change for this a moment ago, the rate of change for your table is a negative 4. A negative 4 means that your change in y over your change in x. So that negative 4 is the same thing as a negative 4 over a 1. So if your y goes up by 1, that means your x goes down by 4. So if my x goes up by 1 to become a 0, my y is going to have to go down 4. So to go from a 5 and then go down 4, that means my y would be a 1. So if x is 0, y would be a 1. So that means that my y-intercept for function 2 would also be a 1. So that means that my correct answer is B. The y-intercepts for the two functions are equal. Let me explain to you one more time, just to make sure. This is probably the hardest one on here because you got to know a lot of stuff. So the y-intercept for the equation is 1. To figure out the y-intercept for the table, we had to figure out what our y would be if our x were a 0. And we found our rate of change was our change in y over our change in x, and our rate of change was a negative 4, which is the same thing as a negative 4 over 1. So that means if our x goes up by a positive 1, our y would have to go down 4. So for this to go up 1 to become a 0, this would have to go down 4, which is why our y-intercept would be a 1, which is why the answer should be B. Number 14, Moira placed $2 in an empty piggy bank and then added $3 every month. The same day, Nathan placed $5 in an empty piggy bank and then added $3 every month. The graph below represents their savings. Which statement is true? Let's see. Nathan is saving more money per month than Moira. No, he's adding $3 a month and she is adding $3 a month. So they're saving the same amount. So nope, he's not saving more. That can't be it. At the end of 5 months, Moira will have more money in her piggy bank. Well, no. The amount she started with was only $2. Remember, this is called her initial amount. His initial amount was $5. But they're both putting in the same amount every month. So at the end of 5 months, she will have more money. Well, no, that can't possibly be right because she started out with less and they're still putting the same amount in every month. So nope. And you can even tell by the chart here. He is always a little bit ahead of her, if you look at there too. He's the triangles that are right here above hers because they keep putting in the same amount every month, but he started with more. Moira is saving more money per month. No, they're both saving $3. The initial amount of money in Nathan's piggy bank is greater than the initial amount of money in her piggy bank. That's what I just said. Yep, that one's the right one. Number 15, the fabric store sells cotton for $7 a yard. The price of special occasion fabric, so that's a different kind of fabric, is shown in the graph. So I'm looking in the graph and it says for 1 yard, it costs $9. For 2 yards, it costs $18, etc., etc. So it's actually talking about two different types of fabric. So it says compare the functions' rates of change. Well, for cotton, if it's $7 a yard, okay, so it would be $7 for 1 yard. It would be $14 for 2 yards, etc., etc. Every single time your X value goes up by 1, your Y value goes up by 7. So the rate of change for the cotton is 7. Every single time you go up a yard of fabric, it increases by 7. So that's your rate of change. Looking at the table, if 1 yard of fabric costs $9 and 2 yards of fabric costs $18, let's make our little imaginary triangle right here. I'm just going to pick this point and this point. So from here to here, whoops, I didn't make that very neatly. Let me try that again. Okay, so I picked these 2 points right here just because. So it went over 2 and it went up from 0 to 18. So change in Y is 18, change in X is 2. 18 over 2 simplifies to 9 over 1, which is a 9. So the rate of change for special occasion fabric is 9. So rate of change for special occasion, and I'm going to abbreviate, is greater because it says compare special occasion is greater. Number 16, Joshua earns a salary plus commission. So what that means when you earn a salary plus a commission, salary is the amount of money you get paid for your job no matter what kind of a job you do. Commission means that the better job you do, it's like extra money that you get for doing an even better job. So he gets paid a certain amount of money no matter how much he does. Then he gets a commission for every painting he sells. So commission is like extra money. So the equation, C equals 40P plus 75. C is his commission in dollars, and P is the number of paintings that represents how much he earns. So we can look at this equation right here and kind of tell $75 is what he's going to get regardless of how much he sells. So no matter what, he's going to get $75. Okay, so that $75 is also, so no matter how many he sells, that's also his initial amount. Doesn't matter what else happens, he's going to start off with a $75 paid regardless. But then you can tell from the equation, he gets $40 for every painting that he sells. So he also gets a $40 for each extra painting that he sells. So where that $75 is his initial amount, he's going to get that regardless of how many paintings he sells. That $40 is his rate of change because every single time he sells a painting, he gets another $40. So his $75 is his initial amount, $40 is his rate of change, and this is all for Joshua. Move this out of the way here. This one is all for Joshua. Then it says that Martin's commissions are shown in the table, and it tells us to compare the functions Y-intercepts and rates of change. Okay, so hopefully we remember initial amount is another word for, hopefully you guys at home are remembering this, Y-intercept. So we know what Joshua's Y-intercept is because we know what his initial amount is. Now let's look at Martin here. So every time when he sells one painting, he gets 115. Two paintings, he gets 150. So for every single extra painting that he sells, he gets $35 extra. So that means that that $35 is his rate of change. Because every single time his number of paintings goes up, the amount of money he makes goes up by $35. Now, we got to figure out what his initial amount is. That is, what he gets even if he sells no paintings. Well, if every time this goes up by 1, the amount of money he makes goes up by 35, well then we're going to assume the opposite. If this goes down by 1, so that he sells no paintings, this is going to go down by 35. So 115 minus 35 is 80. So that means that his initial amount, that means if he sells, so think about it, every single time he sells an extra painting, he gets an extra $35. So instead of going up a painting, let's say he goes down a painting, and instead of selling 1, he sells 0. Well, we're going to take that 115, and instead of adding 35, we're going to subtract 35. And 115 minus 35 is 80. So that means his rate of change is 35. His initial amount, that means what he makes even if he sells no paintings, is 80. We know that an initial amount is the same thing as your Y-intercept. So since the question is asking us to compare the two, that means that Joshua has a higher rate of change, and I'm going to abbreviate rate of change, because Joshua's rate of change is 40, whereas Martin's rate of change is only 35. But Martin has a higher Y-intercept. Remember, Y-intercept also means initial amount, because Martin's initial amount is 80, whereas Joshua's initial amount is only 75.